In this core practical, we're going to investigate the electrolysis of copper sulphate solution. And in the first part with inert electrodes are carbon electrodes. They do not get involved. They do not dissolve in this solution. So they don't get involved in the reaction in that way. And so what we're going to do is investigate the mass change of the anode. The anode is the positive electrode and the cathode is the negative electrode. When the copper sulphate is electrolyzed using different currents, up from 0.2 amps to 0.5 amps. So we will do this first experiment study using inert electrodes. Now a circuit diagram for the apparatus. So first off, we will need a power supply, a source of direct current electricity. Okay, so DC electricity. And we'll need some wires coming out of that. Now, we want to be able to measure current. So we're going to need an ammeter. Now, you wire ammeters in series. We're then going to need a beaker to hold our copper sulphate solution. And we're going to need 2 carbon electrodes. Okay, we need 2 carbon electrodes to put into it. So there's 1 carbon electrode and there's the other carbon electrode, and let's put that beaker together now down here. So this is a glass beaker we'll use, and we'll fill that with copper sulphate. And we'll label that in a moment. Now, also in that circuit, we're going to need something to change the current of electricity. Now, you can have an adjustable power pack, or we could use a variable resistor. So we'll use a variable resistor, a symbol for variable resistor. Oops, a bit too far down. It looks like that, and it has an arrow through it. So there's our variable resistor. And then we go back to the power supply. So let's label that up. Okay, here is our copper sulphate solution. Now, copper sulphate solution is a solution of copper ions, Cu2 plus aqueous. It's a blue solution, okay, and it has sulphate ions in it, but they're not going to get involved. We're not interested in those in this electrolysis particularly, but we are interested in the copper ions. They're going to play a particular part, especially when we use copper electrodes later. Right, this is our variable resistor. This is an ammeter. Here are our carbon electrodes. Now in our first experiment here, we're going to use carbon electrodes. And that's just a beaker down there. So to understand this first experiment, we have to understand what ions we have present. We have copper ions, they're going to be involved. We had sulphate ions, well, they're not going to be involved. We have hydrogen ions, they're not going to be involved because the copper is less reactive than the hydrogen, and the less reactive cation is given off. And we have hydroxide ions, well, they will be involved because if we don't start with a halide ion, a chloride, a bromide, or an iodide, it is the hydroxide ions that go towards the anode. So these are the 2 important ions. On to our next page now. What are the products of the anode and the cathode? The anode is the positive electrode. The cathode is the negative electrode. So let's do the cathode first. Now we have copper ions in solution, so they are Cu2 plus aqueous. They're the copper sulphate ions, the copper ions there. Now they go to the cathode because the cathode is negative. Positive is attracted to negative, and when they get there, they're going to lose their charge, as is always the case in electrolysis at the cathode. These ions turn back into the elements. Now copper as an element is solid. It's a red-brown solid. So hopefully we should see red-brown solid produced at the cathode. Now how do they do that? They gain 2 electrons. Now the anode, as we've already said, we don't start with any halide ions, so it's the hydroxide ions that are produced, or the hydroxide ions are the ions that are going to the electrode. And when they get there, they produce oxygen and water. So to balance that out, 4 hydroxide ions will produce 1 oxygen molecule and 2 water molecules. And they also produce 4 electrons. So those electrons are given off on this side as well. Now, oxygen is, of course, a gas, so we should see that bubbling. So let's have a look at this apparatus. So here is our apparatus now. I've got my power supply here, my direct current power supply. The black is the negative electrode. So that's going through the ammeter, and here is our negative electrode. Here it's plugged in into that crocodile clip, so it's going down to there, into the copper sulphate solution. So that's the cathode. The red is the anode. That's attached to that copper electrode. And this big piece of kit here, this is the variable resistor. So by moving that slider, I can change the current. And goes back into the power supply on the positive terminal. So if I turn that on now, okay, and I've set it already hopefully to about 0.5 amps. It's a tiny bit high, isn't it? So let's see if we can just reduce that by sliding just slightly. There we go, we're down to about 0.5 amps. We're now going to leave that running. We need to leave that running for about 20 minutes for this practical to attract enough copper to this electrode. The copper that is produced is going to be produced on that negative electrode there. So while that experiment's going on, let's get our results table drawn up. Okay, so we need to take the mass of the anode and the cathode, because we're going to have a look at the mass change with both of those. Okay, so immediately we can draw a line right down the middle there. Okay, and we're going to do it at different currents. So let's put current on that side, and we can put that down. So let's put the current is going to be in amps. So we're doing it at 0.5 amps to start with, but we're going to do it at 0.4 amps, 0.3, 0.2. And that will be the experiments we do. So we're going to take the mass of the anode and the cathode at the start and the end. So it's just from that we're going to work out the difference. So we're going to need to have 3 columns on both sides. One for the mass at the start, one for the mass at the end, and one for the difference. Okay, so start, end, and difference. Start, end, and difference. Okay? Let's just make it clear that we've got mass of the anode there in grams and the mass of the cathode in grams. We can draw all those lines in. Put those down a bit further. We've got a rough results table ready to go, and take the measurements as time goes by. So for ease, okay, I've already started taking these readings. We haven't really got time in the video to walk through the whole practical. So let's just say, for the sake of argument, it's 3.342 grams for every one of those. Now at the end of the experiment, we will measure the mass of the cathode. And I've done this before and got a mass of 3.62 grams. So we're just going to use my results from before. So to work out the difference, okay, we need to subtract the start from the end. So 3.62 minus 3.42, and that's going to be 0.2 grams. Now when I did this before, we roughly got these results, so let's put them down like so. So that's going to be 0.16 grams, that's 0.12 grams, and that's going to be 0.08 grams. And every time we use the same anode, and every time it started at 3.52 grams and finished at 3.52 grams. So we can conclude from that didn't get involved in the experiment. Now, when you do this with copper electrodes, the mass of the cathode will increase again as time goes by, and the mass of the anode should decrease by exactly the same amount. So you'd need to do this before and after. So although it's 0 for this, when we're doing it with copper electrodes, the mass of the anode will decrease. And if you look at the theory in the electrolytic purification of copper, it explains why. So we're not going to do too much theory explanation in this video, because this is literally just explaining how to do this experiment. Okay, to understand the theory for when you use copper electrodes, you have to look at the electrolytic purification of copper. Okay, next box down here. What other observations can you make? Well, let's have a look. This experiment's been going a while now, so let's move the camera down a little bit closer, and hopefully we can see these electrodes. Now, this electrode here, this is the cathode, the negative electrode. We are thinking to ourselves right now that the copper ions are going to that electrode, touching it and forming copper metal. Now, we can't see a colour change at the moment because the blue's too strong, but hopefully when we take that electrode out, it's going to look red-brown, okay, because copper will have been plated to it. Now, over the other electrode, this is more interesting now. This is an observation we can see. There's lots and lots of bubbles coming off that electrode. There's lots and lots of bubbles coming off that electrode. Now, if you remember, when we went through this a moment ago, we have the hydroxide ions going to that electrode, turning to oxygen gas, and that would explain the bubbles. So that's been going a few minutes, so hopefully we're long enough to see a change. So let's turn the current off, and let's lift this out now and have a look at the two electrodes. Okay, the one on the left, the black one, that's unchanged carbon electrode from when we started, but look at the one on the right. It's now red-brown. The mass of that electrode will have increased because copper has been plated onto it. And that's how we do those practicals.